Impedance is the total opposition of a circuit to alternating current. It's measured in ohms. To calculate impedance, we must know the value of the resistors and the reactance of the inductors or capacitors. Impedance is represented by the uppercase letter Z. The equation to calculate impedance is Z equals the square root of the resistor squared plus the reactance squared. In the first example circuit, we have a resistor at 1 kilo-ohm, a capacitor at 100 nanofarads, and a 2 kHz supply. The components are in series. To calculate the total impedance, we use the equation Z equals the square root of R squared plus the reactance squared. R squared, 1000 times 1000, equals 1 million. The reactance of the capacitor is 800 ohms. The reactance of the capacitor squared, 800 times 800, equals 640,000. Z equals the square root of 1 million plus 640,000. Z equals the square root of 1,640,000. Total impedance equals 1280 ohms. In the next example circuit, we swap the capacitor for an inductor. We have a resistor at 1 kilo-ohm, an inductor at 1 millihenries, and a 2 kHz supply. To calculate the total impedance, we use the equation Z equals the square root of R squared plus the inductor reactance squared. The equation is the same, but we need to use the reactance of the inductor this time. R squared, 1000 times 1000, equals 1 million. The reactance of the inductor is 12.56 ohms. Inductor reactance squared, 12.56, multiplied by 12.56, equals 157.7536. Z equals the square root of 1 million plus 157.7536. So Z equals the square root of 1,157.7536. Total impedance equals 1000 ohms.